wasn't here yesterday, so when should I take my test?
You'll need to do 2 different advisory periods the next week.
2?
So, just because advisory is not as long as class. So,
Oh.
Tuesday shouldn't be an issue because Tuesday is math priority. So none of your other teachers should ask for you on Tuesday. And then just pick one other day of the week that you don't need to go see one of your other teachers. So Tuesday and Wednesday would be great, but if you need to go somewhere else Wednesday, just do like Tuesday, Thursday, or Tuesday, Friday. Both of the handouts you guys picked up today together make up number 49. So if you would number both of them, and you probably should staple them later, but let's go ahead and wait on that. Okay, so our semester is wrapping up pretty quickly here because we've got next week, and then it's like 2 weeks, 2 days, and then final exams. So we have one more big important section from the textbook that we try to get checked off this semester, and we don't quite have time to do all of that section. It's section 5.3. We don't have time to do all of that before Thanksgiving break, so when we come back from Thanksgiving break, we will hit the ground running with that. But one of the skills that you will need to have in section 5.3 is factoring. So I know you guys have seen factoring before, but we're going to review it a little bit today and a little bit next week as well, so that should not be something that holds you back in section 5.3. So today what I'd like to do is start off on the front page here, where I will remind you of a couple of the factoring types: GCF, difference of two squares, sum of two squares, factor by grouping, and factor trinomials. Then on the back of the front page, I will show you how that factoring that you've learned in the past is going to translate into trigonometry. And then the other page will have you do 10 factoring questions. So, pretty light class period, but this factoring is super important. So if you weren't great at it last year, or if you feel like you've forgotten some of it, then this needs to be your catch-up opportunity. Okay, the first type of factoring we're going to look at is GCF. So let's look at a couple of examples here. So to me, factoring out a GCF is like undistributing. Try to find the biggest number that goes into every term evenly. Think of the biggest amount of variables that would go into both evenly. And then to figure out the rest of your answer, you have to think about what you could distribute 4p cubed to get 16p to the fourth? And then what could you distribute 4p cubed to get 4p cubed? And then there's your answer. Okay, and then do the same thing with these two. Number-wise, you could divide both of those evenly by -6. And variable-wise, you could divide both of them by r to the fourth. So that is the GCF that you should pull out. And again, this is like undistributing. So I'm imagining that -6r to the fourth being distributed to the first term, and it's supposed to be -6r to the fifth. So he's missing an r. And even though these are already the same, if you don't put anything here, then you would never get that term. You need to put a +1 there. -6r to the fourth times 1 gives you -6r to the fourth. Okay, there's just one more of these, and so I'd like you to try this one real quick. For all three terms, try to factor out the GCF. Okay, part of why I want you to do one is because, and this may come up later, sometimes, maybe not this one, but sometimes it's hard to know what the GCF is, especially if it's a bigger number. So I'm going to start this one off incorrectly, but I'm going to do it on purpose. So let's say you looked at all of those and you can't decide what the biggest number that would divide into all of those evenly. This doesn't have any p's, so you couldn't factor out any p's. They all have to have it. But sometimes if you can say, well, I know I could take out at least a 5, start off with what you're sure you could take out. And then just make sure you reevaluate. Do you see how 10, 10, and 4 still have a 2 in common? So the GCF wasn't 5, the GCF was supposed to be a 10. And then so pull out an extra 2. Divide everything by 2, that's what you were aiming for. So it's okay if you don't go straight to the GCF. Sometimes just pulling out anything that you can see, and then once the numbers are smaller, see if there's something else you can pull out. It's better than... I'm sorry? Oh yeah, this should be 2. Thank you. Okay, you guys okay with that? Okay, so quick sidebar here for just a second. Except maybe not if I can't find it. Okay, here's one. Okay, so to me, GCF is probably one of the easiest algebra tricks you've ever learned, and most of the time, at least in pre-calculus, you know, everyone knows what a GCF is. You guys know how to factor those out. You do a pretty good job with that. It's probably not something we really need to dwell on. But I do need to let you see that those of you choosing to go on to calculus, or if you choose to go on to another higher math, just last week, I think we did this last week, we did a few practice FRQs, and of all 5 of these we did in my calculus classes, the one they thought was the hardest was this number 1, and the reason why they thought it was the hardest is because they had to solve this without a calculator, and it really boiled down to one thing, and that's if you can see GCF. Simply being able to take out a GCF is great, but if you can't recognize when to do it, then you still kind of get hung up in later. So notice this big term has a 2x plus 4 squared, and this term has a 2x plus 4 squared. So since both of these had a 2x plus 4 squared, again, this is not my opinion. Their opinion was this was the hardest FRQ, and it was that step right there. GCF, a lot more stuff going on, but it's still factoring out a greatest common factor. And then after that, the algebra was pretty easy. So just because you can do GCF, you still need to be aware that you need to put in good effort in trying to identify when there's a GCF, not just when you're told. Okay, the second type we're going to look at is the difference of two squares. So the name kind of gives it away. Difference means subtract. 2 is because you have two things, two terms, and then squares because they're perfect squares. So you probably have seen it presented this way, where if we call the thing being squared on the left a and the thing being squared on the right b, this factors as an a plus b and an a what?
Minus b.
A plus b and an a minus b. Difference of two squares is a very common type of factoring, so it's nice to know that pattern. When I look at this question, I can see this is the difference, subtract, two terms, and they're both perfect squares. The thing being squared on the left is 4n, the thing being squared on the right is 3, and difference of two squares always factors as a plus and a minus. This one's also a difference of two squares. On the left we have 1 being squared, on the right we have r being squared. Difference of two squares, one of them is a plus, one of them is a minus. Now, something else to keep in mind is that factoring is really just doing algebraic multiplication. So, same way you guys have been doing all throughout your math career. I don't know if you've ever thought about it, but one of the first things you learn is adding, and then right after that you learn how to unadd, subtract. Then you learn multiplying, and then you learn how to do the opposite of multiplying, which would be dividing. This, you learned how to FOIL, multiply algebraic expressions together. Factoring is undoing the multiplying of algebraic expressions, whether that's distributive property or FOIL. Factoring is just unmultiplying. Okay, sum of two squares. I don't have any examples here, but it's the same idea. Sum means plus. 2 means two terms, and they need to be perfect squares. So, I don't know, let's make up one like this. X squared plus 25 is the sum of two squares, sum of two perfect squares. But the sum of two squares does not factor, ever. So, typically we call things that don't factor prime. So even though I didn't put a bunch of examples there where we just had prime a bunch of times, anytime you see the difference of two squares factored with this pattern, the sum of two squares, don't waste your time trying to factor it. In fact, if you think it does factor, feel free to write down what you think it factors to, FOIL your answer together, and you will see that it doesn't equal that. You're more than welcome to try it, but sum of two squares will not factor. Okay, on to the last two, and these two are going to go hand in hand. So I'm going to talk about factor by grouping, and then I'm going to use factor by grouping down here. So this one's going to carry over some. Now, factor by grouping typically is one that you guys don't practice as much, but factor by grouping is going to occur when you have four terms. So notice all of them in this row have four terms. It's called factor by grouping because you're supposed to group the first two together with parentheses and the last two with parentheses. Always leave this plus or minus sign in the middle. Don't do that. Students do that sometimes and then it causes them issues. Leave the plus or minus in the middle. Group, group. And then, if you can do GCF, you can finish factor by grouping because you just have to do GCF 3 times. You have to take the GCF out of the left two, take the GCF out of the right two, and if it's really a factor by grouping question, do you see how this term has an n minus 2 and this term has an n minus 2? So GCF number 3 is factoring out the n minus 2. So n minus 2 times this is supposed to give me all of that. So 5n squared. And then n minus 2 distributed to this is supposed to give me all of this, which would be plus 3. That is the thing that you could multiply together or FOIL together to get those four terms. Group the first two, group the last two, GCF1, GCF2, and then if these two are the same, that's a good sign because that has to be true. You can do GCF one more time. Those two should match and you can pull it out. Okay, so do y'all remember doing factor by grouping last year? Okay. Again, this one, I have seen this on the ACT before, but I know you just don't practice it as much. So now, there's one catch to factor by grouping. One time that these questions can be a little bit more complicated. And it's a little hard to see why, so make sure you're following along closely here. When I first started this question, I grouped these two together and I grouped these two together. What is this number right here? The plus what? What's that understood? It's an understood 1. And if I distribute a positive 1, that doesn't change anything, correct? Positive 1 times anything doesn't change anything. So that's why I didn't have to address this on this question. Over here though, when I drew in the parentheses, notice I've got 35xy minus 5x. I don't care about that. But because I put in these parentheses, now this negative is going to 56y. And looking at your paper, is the original question minus 56y? Look at your paper again.
Yeah.
It is, so that's fine. But now that I put in the parentheses, this negative is also going to the plus 8, which gives a minus 8. Is your original question minus 8? So as this stands, this right now is not equivalent to the original question because of this negative 1. So you might want to summarize this in words. I will leave this up to you. But if this middle sign is a minus, you have to change or flip this last sign. That way when the negative 1 is distributed, it goes back to the original problem. That way it's equivalent to the original problem. So I will pause here for just a second if you want to write that in words. Only if it's minus do you need to change the last signs. Because of the parentheses you're creating, we are having it distribute. And that changes the question unless we flip that last one. Okay, but other than that one extra step you have to consider, the rest should kind of come together. GCF out of the left 2, GCF out of the right 2. Does it look like I'm doing this one right?
Yes.
These are supposed to be the same. If they're not the same, then you know something's off. And since they both have a 7y minus 1, we can factor it out as a GCF as well. 7y minus 1 times 5x gives me all of that. And then 7y minus 1 distributed to minus 8 gives me all of that. Now, what could happen is this one might say 7y plus 1. And what might have happened is you might have forgotten to switch this last sign. So we need to know all of the factoring methods, but I like factor by grouping because the fact that this and this are the same makes me feel pretty confident that the answer I'm about to write down is correct. So I would like you to try this on one of them. So take a minute, see how it goes for this one, and then we'll check to make sure there's not something you don't understand. Okay, let's see how you did here. So you should recognize this as probably going to be a factor by grouping question just because there's 4 terms. So you should have grouped. You should have recognized that there's a minus sign in the middle that's now being distributed. So if you don't switch this last plus to be a minus, it is not the same question anymore. So we have to do that. I don't know, taking out the GCF out over here looks a little bit easier. We could pull out a 3. Oops. Over here it's a little bit harder, so I'm going to start by pulling out, I don't know, I know 5 goes into both of those evenly. Let's say 5A. So 5 times 20 would be 100. So 5 times 21 would be 105. And 5 times 20 would be 100. So 5 times 18 should be 90. Okay, so 5 was not the GCF, but as I tried to give you a hint a minute ago, sometimes it's hard to know what the greatest common factor is going to be. So I pulled out a 5 because that's all I could see. But now that the numbers are smaller, I can see that I could have pulled out an extra 3. And the fact that these two look the same is a great sign. Factor it out. And then the rest would be 15A minus 3. Okay, and then the last part, I got one more thing to say about this question. It kind of depends on why you're factoring. A lot of times we factor to solve equations, like, and we're going to do some of this after Thanksgiving, but sometimes you would factor in algebra like this. So you could set this factor equal to 0 and solve, and this factor equal to 0 and solve, and you know the solutions to this. And this would be perfectly fine. But sometimes you're asked to factor completely. And if this said factor completely and that's the only skill we were testing, this should not be your final answer, because this still has a GCF of 3. So this is factored completely. Ideally, you pull out the greatest common factor at the start of the question. All 4 of these terms had a 3 common, so you could have pulled the 3 out from the beginning and just carried it down until it got down to your answer. But if you don't do GCF at the beginning, then you need to at least consider it at the end. Otherwise, it's not going to be factored completely. And of course, the benefit of doing it at the start is you're less likely to forget if you make that a habit. And if I had pulled out a 3 from the beginning, it would make all of these numbers smaller, which would just make the work a little bit easier. But okay, and then moving on to the last one, which I'm going to spend just a touch more time on, because these tend to be the most important because they are the most common type. So I'm going to talk about 2 methods. I'm going to talk about guess and check. Guess and check is where we just try to guess how to unfoil this, and then we check it by foiling our answer together. This is what you guys should be practicing. Guess and check gets easier and quicker the more often you do it. And you guys are close to calculus, college algebra, all that kind of stuff. You don't want to have to spend 4 or 5 minutes every time you need to factor a question. But I'm going to talk about guess and check on one of these, and again, I think you should try it all the time, but then I'll talk about the other methods. So, guess and check, if you've got a trinomial, you're trying to unfoil this. So I know the first part of FOIL is supposed to be 3p squared, so I'm going to guess that's probably 3p times p. That gives me the first part of FOIL. The last part of FOIL is supposed to be -5, and there's 2 things that multiply to -5. One in -5, -1 in +5, and sometimes the order matters where you put them. So Since this is a guess, I'm going to just put down, I don't know, +1 and -5. That multiplies to -15. Before I circle this and say this is my answer to this factoring question, though, I need to actually check. I've already checked the first part of FOIL and the last part of FOIL, but I also need to consider the outer part of FOIL combined with the inner part of FOIL. And what I currently have written down gives me negative or minus 14p, and I need it to be minus 2p. So, unfortunately, that's not the answer. So the reason why this gets quicker is you make better guesses, more educated guesses. But at some point, if you said, what if I put the -5 here and the +1 there? Now the outer part of FOIL is 3p, and the inner part of FOIL is minus 5p, and those terms combine to be the minus 2p. So guess and check. Guess the FOIL, or guess how it would FOIL. Actually FOIL it to check. If it works, circle it and move on. If it doesn't work, try putting the stuff in a different spot. Try finding a different way to multiply to -5. Try something different. Okay, I'm going to erase this to give myself some space, but I'd like you guys to keep that there. So all the rest of these, I'm not going to talk about guess and check anymore, because my guesses, I can usually guess it right the first try most of the time. But factoring is just too important. In fact, it's probably the most important thing you guys do in Algebra 2. The most important skill as far as moving on to basically anything else except maybe AP Stat. AP Stat probably doesn't need much factoring, if any. So sometimes you have to have a backup plan. Someday you guys might take college algebra and there might be 10 questions on a quiz after you factor it, and you can't just say, well, I couldn't figure out how to factor this one. Also, sometimes guess and check just takes you a long time. You're just not thinking of the right number combinations. Or what if this doesn't factor at all? If the only thing you ever do is guess and check, you never know that it doesn't work based on guessing, because you don't know if you just haven't tried the right things. So eventually you just give up and say it must be prime. So this is where you need to have a backup method, and I'm going to ask you to take down notes the same way I do the notes here on these 3 questions, doing the product sum method. But I fully understand that some of you may not have learned the product sum method in Algebra 2. There's at least a dozen ways to do factoring. I don't know all the ways to do factoring. I don't need to know how to factor 12 different ways. So if you learned a different method in Algebra 2 that you like better, after these 3 for notes, you're welcome to use it. You just have to keep in mind that if you get stuck on one and you need help, I probably don't know that method, so I can't help you with that method. I can help you with this method. And as I show you this method, I'll talk about why I like this method over the others. But if we think about the name, what does product mean in math? That's what sum means. Product is multiplication. So when it says product sum, we need 2 numbers that multiply to something, and then sum 2 numbers that add to something. So the numbers we want to add to is b, and when I say a, b, and c, it's the same a, b, and c from quadratic formula. So in this question, b is 2. I'm going to want to find 2 numbers that add up to b, but multiply to a times c, which in this question would be -15. So if you can think of 2 numbers that multiply to -15 but add up to -2, you're ready to move on. If you can't think of that, then you should just make a list of everything that you can think of that multiplies to -15. That sounds like a lot, but there's really only a couple things. 1 and 15, either one could be negative, or 3 and 5, and either one could be negative. Which one of these number sets that multiply to -15 also add to -2? So these 2. Now, be careful here. This is where I lose students sometimes, and they think, oh, okay, those are the 2 numbers. That must mean you just put a +3 here and a -5 there. That's not what you do. this would give you negative 15, not negative 5. Unfortunately, these two are not the answer yet. What these two numbers tell you is a way to make this original question look different. Leave the 3p squareds alone, leave the minus 5 alone, but in the middle, we're going to make b look different. Instead of saying minus 2p, we're going to use these two numbers. We're going to say 3p minus 5p. Or, if you'd rather, minus 5p plus 3p. Doesn't matter. Do you see how this is equivalent to this? That's why this part of it's important. If we change negative 2p to something that's not equivalent to negative 2p, then we're solving a different question. Okay, the other thing I have to ask is, why is this better than this? Yeah.
Now you can put parentheses around both of them, about those two terms.
Okay, and what do we call that?
FOIL.
FOIL is when you're checking your answer. One more time. Right. Factor by grouping. If you know how to factor 4 terms, which you need to know how to do this anyway, one of the reasons I like this method is because, in theory, this is the stuff you have to practice, and then you should be good at finishing it. Now, if you pick any other number combination, the factor by grouping is not going to work out. It's this special combination of numbers that makes the factor by grouping work out. But then you can group the first two, group the last two. If the middle sign's a minus, you need to switch the last sign. GCF out of the left, GCF out of the right. Another reason why I like this method is because in factor by grouping, you anticipate that these two are supposed to be the same. So if they're not, you know something was off right before you put down your answer. But notice how we get the same thing that hopefully you could get with guess and check, but if you couldn't, then there's the answer. So I prefer this method over all the others because it gives you more practice on factor by grouping, which you guys typically don't get a lot of practice on. Indirectly get practice on GCF. This method works 100% of the time. If this was a problem that didn't factor, if I listed everything that multiplied to a times c and none of it added up to b, that's how I would know that it doesn't factor, and I would call it prime. Whereas if I'm just doing guess or check, I never know if I just haven't guessed the correct thing yet. And the fact that these two need to be the same before you get to your answer just gives you a little bit of confidence right there at the end. Okay, so let me say those steps one more time, or 2 more times, sorry. So let's pretend like we tried guess and check. We either couldn't figure out the right number combination or we just thought it was going to take too long. So let's just go straight to product sum. And again, after these 3 questions, you don't have to do product sum ever again if you have a different method you like. But product sum, basically we want to change this from 3 terms to 4 terms, but 4 terms that factor by grouping. So to do that, we have to think about what a times c is, and we have to think about what b is, and we have to find 2 numbers that multiply to this but add up to that. So really, if you can think of it right away, then just stop. But worst case is you could just list out everything that multiplies to 10. There's only 4 things, assuming no fractions, and of course we don't want to do fractions. Pick out the ones that also add up to b. And the way we utilize these is we rewrite the question, and in our b term is 11v. I'm going to rewrite it to be 1v plus 10v. That's the same as 11v. I'm just changing its appearance. And because these numbers meet these 2 requirements, I know the factor by grouping will work. So at that point, you should feel like you are just a moment away. Looks like 2v plus 1 and v plus 5. Now, that takes longer than guess and check if you guess and check pretty quickly. But also, if you know this method and you're used to practicing it, it doesn't take that long. It takes a minute, maybe 2 minutes, but it's not like it's a 10-minute question all of a sudden. Okay, and then one more. Now, if I try to do, there's a good lesson in this one, so even if you feel good about the last two, is that how y'all learned factoring last year? It kind of changes from year to year. So Miss Polson did it this way? No?
Yes.
Oh, she did? Okay, I'm seeing some yeses, some no's. What about Mr. Smith?
He
Kind of did both.
He did it in an X.
Oh, okay, yeah. Okay, anyway, so if I try to do A times C and B here, I can see B is 66. What is 9 times 21? Huh? Okay. Did you do that with a calculator or in your head? Okay. Do you see how, we can do this, but do you see how it's going to be hard to think of two numbers that multiply to 189 but add up to 66? You see how it's harder just because these numbers are bigger? Well, sometimes that's just part of how it goes. But if you start off small, like 1 and 189 are pretty far away, then you can try 2, but 2 doesn't go into it evenly. And then you can try 3, and then this gets smaller. And then you can try 4 or 5 or 6. Eventually you will stumble on that. But what we started class with, and what I said is you guys can do but you don't utilize enough, is GCF. All three of these have a 3 in common. So not only should you take out the 3, it's going to make your life a lot easier if you do it at the beginning. Because 3 is going to be part of your answer, and we can just carry it along till the end. But then I can just focus on this part. Now the A times C is only 21, and the B is 22. So what are two numbers that multiply to 21 but add up to 22? 1 and 1. So instead of saying 22K, I can say 21K plus 1K, or you could say 1K plus 21K. Either one works. They both balance out. So now that I have rewritten B in the way that this method pushes you into, now I can take a GCF out of these two, a GCF out of these two. These two are supposed to be the same, and they are, so good sign. The rest of your answer is K plus 7. But one thing to note there, if there's a GCF, just pull it out and keep it as part of your answer all the way through. It makes the rest of the question easier. You don't have to always deal with big numbers just because there's big numbers there. Okay, so again, if you have a different factoring method from Algebra 2 or even Algebra 1, that is fine, but just know that I probably don't remember that method, so I can't help you if you get stuck. I like this method, reinforces GCF, reinforces factor by grouping, always works. Generally, you have some confidence if your answer is going to work at the end. And on questions that don't factor, this doesn't work. If you list everything that multiplies to A times C and none of them add up to B, then that's how you can know the question doesn't factor, for sure. Okay, on to the back page of this. So again, this doesn't apply to us till we come back from Thanksgiving break, but I need you to understand that factoring algebra type of equations is going to translate directly with factoring trig stuff. So when I look at this question, this looks like the difference of two squares. So factor does the difference of two squares. Jonathan, you have the pass here? You have the pass? Did you just check in?
Just a second.
My dad's I don't just
Okay. Just make sure that they update that. Okay, but looking over here, do you guys see how this is still the difference of two squares? We have 2 sine x being squared on the left, 1 being squared on the right, and the difference of two squares always factors as a plus and a minus. The only difference between how I factored this, which I know you feel pretty comfortable with, and this, is they weren't x's, they were sine x's. But otherwise it's the same thing. 2x plus 1, 2 sine x plus 1. 2x minus 1, 2 sine x minus 1. They're not x's, they're sine x's. How would you factor this question number 2? What method? Okay, GCF. Same thing over here. If both of these have a cosine, you can factor out a cosine GCF. X's became cosine x's. X times x plus 1, cosine x times cosine x plus 1. Looks more complicated, but it is the exact same reasoning. Okay, somebody else for question 3. What would your first step in number 3 be?
Difference of two squares.
We should just put
You
x
could.
squared in front of parentheses, and we got x squared minus 4.
Okay, good. What is it called when we put this in front of the parentheses? GCF, okay. So, the same way over here. These two have something in common. It's a secant squared. Okay, this factors more because this is still what?
Difference of two squares.
Okay. This still factors, oops. This still factors more because it's still the difference of two squares. You've got a secant being squared on the left and a 2 being squared on the right. Compare this answer to this answer. The x's have become secant x's, but the factoring is the same. If you can factor this, you can factor that. Okay, question 4. This is a trinomial, but a is 1, so you should probably be able to get this with guess and check. But if you can't, it's better that you spend a few minutes and do the product sum method so that you can factor it correctly. When you see this in section 5.3, when we come back from break, if this intimidates you, you can pretend like these cosecant x's are just x's. Factor it, and then go back and say, well, wait, they weren't really x's. They were cosecant x's. But otherwise, same thing. Okay, and then last one, another trinomial. A is not 1, so it's a little bit trickier to do with guess and check. But this would be a 2x plus 1 and an x plus 1. So that means this, that's set up the same way, is going to factor as a 2 sine x plus 1 and a sine x plus 1. The x's have become sine x's, so that's the only difference in the foiling part of the answer. Now, I want to say one more thing on this page, and then you'll have the rest of class to do the 10 factoring questions, which should be plenty of time. But what we try to do in section 5.3 is we will try to do some section 5.3 is about solving equations. So as you guys should know, a lot of times when you did factoring in algebra, it was to solve something like, what if this equals 0? And if you can get this times this to equal 0, you can either figure out where this equals 0 for one answer, or set this equal to 0 and solve to get another answer. You remember doing that? We're going to do the same thing in section 5.3. Sometimes we'll pretend like this is supposed to solve for 0. You factor it. You set this factor equal to 0 and solve. And you set this factor equal to 0 and solve. The only real difference comes in algebra. This is x equals and x equals. So this was the answer. You got to circle it and move on. What we will do in section 5.3 is we still need to solve this. We will still have to think about where sine is -1/2 and where sine is -1. So other than a little bit of unit circle at the end, the work behind solving those is what we're trying to build up to. So if factoring is a weakness of yours, you need to put in a good effort because it will come up quite a bit in this section. So to finish up today, the last page, again, all of this makes up 49. All of this will need to be turned in, but do those last 10 questions. I don't have the answers worked out on my website because factoring questions you can check by foiling, especially if you're doing guess and check. You should be checking your answers as you do them. And there's only 10 questions there, so really no reason for you guys to have any homework. I believe you've got about 45 minutes to get that done. So do those 10 and then turn in all of 49 in the Google Classroom, and then you can call it quits for today.
We both 49.
Yes, all of it's 49. Of course, if there's any that you're getting hung up on, you guys are welcome to work together and or ask me. But try guess and check on all of them. Probably not a bad idea to force yourself to do the product sum method a couple times just to make sure you know the method. And we will practice a little bit more factoring next week as well. We will also do just a tiny bit of semester exam review next week, just so that you have a few questions done from that. But it's nothing to worry about. We won't move on to new trig stuff until after Thanksgiving break.
That's nice. That's worse. What's that?
Ready, right?
Yeah, I was running as you were talking. This plus it does. This one's easy. Yeah, I did.
formulas when you're solving an equation. These aren't equations, you don't have to solve them, just factor. So, yeah, you need to think of two numbers that multiply to negative 35 but add up to negative 8.
Yeah, it's easy.
Okay, well, but if you do them in order, is it negative 35 and negative 8?
Yeah.
Okay, so if you do the product sum, what's two things that multiply to negative 35?
Negative 5 and 7.
Okay, let's start off with 1 something.
Oh, 1 and negative 35.
Okay. These add up to negative 8?
Hmm.
Okay, or we could switch which ones are negative. Does that add up to negative 8? Okay. Does 2 go into this? Does 3?
No.
Does 4?
No.
Does 5?
Yeah.
Okay, how many times does 5 go into it?
7.
These add up to negative 8?
No.
Okay. Let's switch to negative. Do these add up to negative 8?
No.
Okay, the 6 go into it?
No.
The 7 go into it?
Yes.
Okay, but I really did that here. So now I've exhausted the list. Is there anything that multiplies to negative 35 that adds up to negative 8?
No.
Then that question doesn't factor.
Oh, so it's prime.
It's prime. And without doing this method, if you only do guess and check, you don't know if you just haven't guessed the right thing yet, and that's the problem. But if you really write out everything that multiplies to A times C, and none of it adds up to B, then it won't factor. And you don't have to spend any more time.
Thank you. No, this is about the main, you know what Coach Prime is?
I do.
Okay, I know you should incorporate that, in the prime, Coach Prime, just something for you to think about.
What's it got to do with the mean?
No, I'm just saying like in the future, like something's prime. I don't know, I just made me think of them.
It's like your grade, like he was doing real well at the start of the year, and then now he loses everything.
Yeah, that's good.
I
You know,
know.
I guess, you could, yeah.
I like this one.
Yeah, I do too. It took me a minute to get it, but now I got it.
I don't get it.
You never heard why was 6 scared of 7?
No.
Because 7, 8, 9.
Oh.
That one took me a minute.
You guys have heard that part before, right? Okay, well this is one step further. This, where's this number coming from?
Because it's the because.
Cause 7, 8, 9.
Yeah.
Cause.
I'm talking to blaming me.
That's it. That's what I was already done.
You can always send me memes too. If they're good enough, I'll use them.
I find one.
We should like
No, even better. What if I made
Bro,
one?
we have to work on that.
Huh?
What if I made a meme?
You can make one. But don't spend too much time on it, because I might not use it.
Of course not.
It's gotta be math related. It's better if it's clever,
Alright. Alright.
and it helps if it's fun.
It'll be funny. I can guarantee that.
Like, I'm not using it.
It can't just be a graphic or grade.
You want to see one?
Huh?
You want to see one?
Do I wanna see you make one?
No, you want to see one.
Well, email it to me. Because if I decide to use it, I need to have a copy of it, so.
It's kind of complicated though.